This is a Triple J podcast.
Hello, welcome back to the Science with Dr. Karl podcast and our first episode for 2025. Whether you are a long-time listener returning to the podcast feed or you've stumbled upon us for the very first time, you might be wondering, who is Dr. Karl? Dr. Karl is an Australian legend. He's a qualified scientist, doctor and engineer. He's got degrees in physics and mathematics, biomedical engineering and medicine and surgery. He's also studied astrophysics, computer science and philosophy. Dr. Karl has been a science communicator and broadcaster for years. He's written many books and he's lived what feels like many lives. He's worked as a physicist, a labourer, a roadie for bands, a car mechanic, a filmmaker, a biomedical engineer, a TV weatherman, a science reporter, and a medical doctor at the Children's Hospital in Sydney. With this wealth of knowledge, every single week, he answers curly questions from the Triple J audience. So every Thursday live, people will send in their questions, they'll jump on air with Dr. Karl to ask them, and he'll try his best to make sense of them. And if he can't, well, he'll give you a story or an anecdote to send you on your scientific journey. If you want to ask a question live, you can do so every Thursday from 9 a.m. Australian Eastern Daylight or Standard Time and hop on air with us at 11 a.m. during Science with Dr. Karl. Or maybe you can only listen to the podcast, and that's where this comes in. We package it up for you every single week and get into some of the big questions, maybe following themes, maybe getting some guests on to really get into some niche topics. This week, to kick us off, we just caught up. We had questions about AI, about the UV index, quantum computing, and also some things that people had seen on Facebook that they wanted to get clarification from Dr. Karl on. I'm Lucy Smith. I host the Science with Dr. Karl podcast and help you get your questions to him every week on Triple J. So let's get into it. Welcome back.
Oh, and I'm so happy to be here. Hooray for 45 squared, which is 2025.
I see. So is that what we're calling this year, 45 squared?
Yeah, the next one coming up is 55 squared, which is 3025, and you have to wait a whole 1,000 years before that happens. But we'll hang in there and see what happens.
Oh my God, that's huge though. How was your break?
Relaxing and family and friends and good times. How about you?
Beautiful. It was fun. I went to New Zealand. I went to Wollongong, kids from the Gong, came back to Sydney, and I feel like so much has happened even in the last 3 weeks that people are going to have questions about.
Yes.
Some stuff obviously that we're seeing overseas with these really catastrophic events when it comes to, say, the wildfires, earthquakes, etc. If you've got a question about that, you can send it in. But also some good news at home as well. So we had the case of that guy who was found after hiking and had been lost since Boxing Day.
That's 2 weeks.
Yeah.
Well, we do know that you burn up fat at roughly 2.2 kilograms a week. So if you eat nothing, after the end of a week, you will have burned up 2.2 kilograms of fat. Mm-hmm. You start off for the first 36 hours burning up glucose you've stored in your muscles. You call that glycogen. And once that's gone, you're into the fat burning. And we know that number because a guy lost 100 and something, 10 kilograms of fat by not eating for 54 weeks. Do not do this at home. It's very dangerous. People have died from starving themselves. Various things happen. But we have that number. So this guy who was lost in the snowy mountains, 2 weeks lost. Well, if he had nothing to eat, he would have been able to survive on his 4 and a bit kilograms of fat. Mm-hmm. Men, 15, 20% fat, women a little bit higher. So we've all got fat for emergency store. And luckily he had a little bit of food, and so that wasn't the problem. And he survived and he didn't die of exposure. Hooray, happy ending. I love a good happy ending.
Yeah, drank creek water and found 2 muesli bars that
he found?
Yeah. That he found a pack that maybe some hikers had left there previously accidentally.
Oh, my
God. It had 2 muesli bars in it.
Yeah.
So, oh, my gosh, like, of course you don't want to litter, but thank you to those muesli bars. My goodness.
Sure. And while you can survive with not eating, your brain goes a bit fuzzy and your glucose level goes low. And the guy who actually survived for 54 weeks, his glucose level went to such a low level that if it happened to you and me in a short period of time, we'd be fuzzy and we couldn't think and we couldn't work out how to catch a bus from here to there and then catch a train. But he got used to surviving at such a low level. In the case of our guy, having that extra bit of food kept the brain functioning at a high level.
If you want to check out the full story, head to ABC News right now. Dr. Karl, should we get into our first question for 2025?
Yes.
Let's do it. 45 squared. Liam in Geelong. You're kicking us off. What do you want to know this morning?
Hi, doctors. My question is to do with the sense of smell. And when we get used to a smell, like, say, we can't smell our own home, is that happening physiologically or psychologically? Like, is our brain blocking it out?
Almost certainly the brain. So Frank Zappa, the great philosopher, got it right all those years ago when he said your brain is your main sex organ. So it doesn't matter about the pink bits or the squishy bits, it's all happening inside your brain. He also said that politics is the entertainment division of the military-industrial complex which runs the world. Let's just leave that for a side and get back. So I was listening to an interesting podcast about how tiredness seems to happen in the brain, and if you can block the tiredness signals from getting from your muscles when you're running or pumping iron, if you can block them from getting to the brain, which they did with electromagnetic impulses, blah, 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 you keep on going. So you've got your brain in that little brain box, the skull, and then you've got all these peripheral things, and one of the peripheral things is your sense of smell, and you can block it and override it. So is that kind of answering your question, that smell happens once your brain interprets the incoming signals? Is that kind of helping, Dr. Liam, or have I missed the point?
Yeah, I was just thinking, like, I couldn't smell my own house, but I come back after a holiday and I can smell it. And, I just didn't know if it was going to be from the organ of the nose or the brain itself.
Oh, okay, that's a different one. So we spent about a quarter of a century test driving four-wheel drives in the Australian outback, and every time we'd come back to the big smoke, literally we could smell it about 80 to 100 kilometres out of town. Wow. Whether the big smoke was Perth or Sydney, and you'd begin to smell this, usually a burning smell, kind of like a mixture of mown grass and cooked pizza. And we could say, can you smell that? Yeah, oh, well, and we'd be 100 kilometres away from the big city. So when you come back, it does it. You are smelling something that you haven't smelled for a long time.
But then also I know what you mean, Liam, and I know what you mean, Dr. Karl, because my best friend says that my family has a smell, and it smells like our linen, our bed sheets, pillows, etc. So when she's, at different points when we've had a sleepover at my family home way back when, she'd say, this is what your family smell is.
And of course there was a case of the woman who could smell Parkinson's disease, and we're now getting more into being able to smell different diseases. So, hey, we are discovering new things about the smell and our own human physiology in 2025.
Thanks, Liam.
And in fact, just this morning,
awesome. Thanks so much.
I heard on a podcast, we've just discovered that the human skin has its own immune system, separate from the rest of the body. Oh, my God, what's going on?
I feel like we should talk about that a little bit later on. Also, Dr. Karl, I forgot to mention, we are giving away a prize for the first episode, to celebrate the first episode, giving away a prize to the best question this morning. So if you've got one, 0439 757 555, you could win a Triple J prize pack. Let's go to Launceston with Amelia. Now, Amelia, I read this question on the text line and it broke my brain. What have you got for us?
Sorry, hey doctors.
Don't apologise, it's me.
Hi, Dr. Amelia.
According to physics, I know that two objects can't truly touch, but I mean, if someone were hypothetically exposed to ionizing radiation, could the free electrons that are caused from that ionization potentially produce bonds with other nearby atoms, making it an exception to this rule?
Dr. Karl, can you put that in layman's terms?
So,
Amelia, what do you do with yourself? Are you a scientist?
Not wish. I'm studying at the moment.
Oh, gosh. Dr. Karl, over to you.
Everything is made of atoms, and they look like a mini solar system, and in the middle is a heavy lumpy bit that's positively charged, and instead of the planets going around, you've got electrons, which are negatively charged. And so if there is an atom in your skin, which is right on the outside, and there's an atom in the floor, those atoms never can touch because they've got these repulsive effects of the electron clouds. And so Amelia is saying, but suppose you rip off some of the electrons, in other words, you make an ion, can you get some sort of contact, either that you get the inner electrons getting closer to each other, or you get an electron jumping from one atom to another, forming a bridge between the atom in the floor and the atom in your skin. And I think that'd be, wow. Geez. That's a big question, Amelia. I reckon you could have that make and break. Like, part of me is thinking of our little reptile friend that's the only one that makes noises, the gecko, the atomic gecko. And the gecko can do this weird thing of running across water, then oil, and then mud and then stick to your ceiling. We cannot make a sticky tape that does that. And what the gecko has is atomic contact. So the gecko has a body. The body has 4 legs. Each leg has a bunch of toes. The toes have got smaller things hanging off them, which go down to smaller and smaller. And finally you end up with setae, S-E-T-A-E. And then they got little smaller subsetae. You end up with these microfibers that are down to literally atomic thickness. So you got a leg, and you look at the leg and you can see it, but as you keep on going smaller and smaller towards the end, you've got stuff that you cannot see with the human eye or even with an average microscope. And the way that the gecko sticks to the wall upside down, even when it's run across oil or anything, is the van der Waals effect. So in the ceiling, there is an atom that has electrons, but the electrons are not evenly wrapped around that atom. There are some more on one side than the other, so slightly small, more or less negative. And then in the atom at the end of the gecko's foot, the electron cloud is not completely even. So it might be more negative or positive. And so you have fluctuating positivity and negativity. This is called the van der Waals effect. And so the gecko sticks to the ceiling by atomic forces. And we're starting to make gloves from this stuff. So I'm thinking yes and no, and I don't know. Dr. Amelia.
Amelia, you have truly bamboozled us.
You have. I reckon you could be onto something there, Amelia.
Does that help for now
so.
at least?
Oh, absolutely. I mean, that's definitely intriguing, the fact that they're actually making gloves now from this gecko. That's wow.
Yeah. Okay.
From the gecko-like material.
Yeah.
They don't get geckos and beat them with hammers. And
Get the sticky stuff, yeah. We got Mark in Eora. Mark, you got a question about coffee?
Hey, doctors. Yeah. My question relates to coffee. So I love my coffee. I buy one in the morning and I'll sip on it all day. I cop a lot of flack from my work colleagues, actually, because I'll keep this coffee. I'll just be sipping this coffee. But it changes. I find that it changes flavour as it gets colder and it actually gets stronger. And I was wondering if you could explain why that happens.
Okay, so the first thing is that we've known for a while that having coffee is good for you. And just over the Christmas period, it turned out that the most goodness comes if you're the sort of person who has one coffee in the morning and none in the afternoon. You'll still get some goodness, but your maximum life extension effect comes if you have just one coffee a day in the morning. Secondly, in coffee, there's caffeine and about 2,000 other chemicals. And the ratio of those changes as the more volatile ones during the day will just waft off into the air and vanish, leaving behind the other flavours. So I think in coffee-making term, how do you pronounce it? Is it ristretto? Ristretto? Ristretto, yeah. That's the very first couple of mils of coffee, and I've tried making it at home in my little coffee machine. I've got a little old atomic thing. The first 3 mils tastes differently from the next 3 and the next 3 and the next 3. And if you actually just try a little bit, they all taste different. And what's happening is that you're dealing with a dynamic liquid that is changing. So firstly, the liquid itself is changing during the day, but then secondly, the temperature is dropping. Once the temperature has dropped down to ambient room temperature, I'm guessing that effect of the temperature dropping and how much it excites the receptors in your tongue is one effect, but now you're dealing with the fact that the volatiles are just going to evaporate off during the day, leaving behind with something else that apparently, according to the baristas, is not the most optimal.
So you don't zap her in the microwave, Mark? You just let her go?
No, I just keep drinking.
I've got a confession. I'll actually, when I've had a coffee, I will add water to it, and I'm working on a principle that those coffee atoms, whatever they are good for me. And so whether I have them pure or with a bit of water doesn't matter. And people go, oh, that's disgusting. And I kind of agree with them, but I still have it.
And you know what? If you're going to drink a cold coffee, at least it's cheaper than getting an iced latte, Mark.
Oh, yeah, absolutely.
Yeah.
It's a rot, man. It's a rot.
Don't get me started, Mark. All right.
They didn't even do anything.
Earlier, we answered a question about when you become really, really ingrained with the smell, you kind of don't recognise it. I feel this is on a similar vein. Beck in Trafalgar, what's your question?
Hi, doctor. So my question is, how come we can stand the smell of our own farts but not other people's?
It's a combination of habituation, as we talked about before, getting used to something, as well as an important bit of self-love. You've got to like yourself. You've got to enjoy yourself. That's my fart. That's a good fart. It happens whenever I have beans. I like beans. Beans are good for my diet. They make me feel good. I happen to fart. So what? Therefore, so being able to accept yourself and like yourself is an important part of life. And some people don't do that fully.
Yeah, Beck, self-love.
Self-love, bit of self-love.
which is why it's bad when maybe you let one rip and you go, oh, that wasn't good.
It is weird when you let one rip and it's really bad and you go, oh, my God.
Yes.
Yeah, and then there's other people around who you might be friendly with and they then react even more strongly.
You say, get out of here.
Yeah.
Okay, all right. Does that help, Beck?
That does, thank you.
Okay. Hey, we got Kieran in Nam here. Now, Kieran, you've got a question about the UV index.
Yes, I do. Hello, doctors. Lovely to talk to both of you. So I am so confused by the UV index. Like, my understanding is it used to go from 1 to 10, and then they added 11 for Australia, like Spinal Tap or something. And then I see it going up to 12 now. And I was in Brisbane the other day, and it went up to 13. I'm like, what is this scale? Like, Are you just going to keep adding random numbers? Is it a, what do you call it, like a normal scale, or is it like a logarithmic scale? Like, can you just explain what is going on?
Look, those questions I can't answer, but I can give you some of the basics, which is that outside the atmosphere, UV makes up 10% of the sunlight. By the time it gets to the ground, a lot of it's been absorbed, so only 2% of the sunlight is UV. About 50% is heat and about 48% is visible light. The UV scale ranges from 1 to 11 plus. I haven't come across this 13. I've got to do some more reading, so I don't know. So
you need to go and hang out in Brisbane.
Well, and other parts of Australia. So low, 1 to 2 is safe for most people with minimal sun protection. Then 3 to 5, that's when you start wearing the sunglasses and applying the sunscreen. Although if you talk to the dermatologists in Australia, they'll say whenever you leave the house in Australia, always put on sunscreen, but we'll get to that. Highs around 6 to 7, very high. 8 to 10, you've really got to take extra precautions and limit your outdoor activities. 11 plus, even a very short exposure can cause damage. Now, Australia is close to the equator and it's very dry, so a lot of the UV comes straight through. So we tend to have the highest UV levels worldwide. Even in winter, they can be harmful. So in June, July, while it's less than 2 over Tasmania, even though it's in June, July, winter, in far north Queensland and Northern Territory can be 8 to 9 at the same time of year. So then, whether it's a linear scale or whether it's... that I don't know. I'm sorry, I can't help you with that. I've got to read up on it.
Who could help us with that?
BOM, B-O-M.
Yeah,
our
okay.
good friends at the Bureau of Meteorology.
Yeah.
And also the
I'll look
skin
on their
cancer
website.
people. Who's that? There is a skin cancer organisation in Australia. Can they ring in? What's the magic number?
Oh, the Melanoma Institute or...
Anybody who knows about this.
Cancer Council,
Yep.
yeah.
Cancer Council, yes.
And, you know, it's something that's been quite prolific in the news recently because people are using that UV index to actually track when they can tan and get in the sun and get the most optimal tan lines. I know,
Tanning
I
is
know.
bad for you.
It's you know, and it's wild to see this messaging or at least this kind of trend coming back in 2025. So use the UV index as a metric to be sun safe. Of course, you can learn more online. But yeah, it'd be interesting to know, Kieran, you're right, because what is
it's
the
a weird
scale?
scale.
How do they keep adding numbers to it?
Yeah, ring us. Otherwise, I'll have to do the homework, and you wouldn't want me to do that.
And with rising temperatures, is that scale only going to get larger and larger? Very interesting.
The BOM did have to introduce a purple colour about 5 years ago for heat in Australia because of global warming. So who knows? We need somebody who knows.
Thanks, Kieran.
Thank you, Kieran.
Thanks so much, doctors.
Hey, we got Sam in Shepparton here. Dr. Sam, you're looking ahead. What's your question?
Yeah, hi doctors. Thank you so much. I am kind of asking you to predict the future, but apart from AI, what sort of trends or inventions or emerging science are you seeing that will most greatly change humanity over the next 100 years?
I'm seeing two major trends. One in physics, there's these major problems with dark energy, dark matter, black holes and the missing dimensions. And when we solve those, they will cause revolutions to our society's technology that we can't even imagine. So who would have thought that when Becquerel put some salts of uranium that he got from Africa on top of a photographic plate, in France in the late 1800s, that would give us quantum mechanics and radio and X-rays. He had no idea that sort of stuff would happen. The other big one is going to be genetics and being able to treat diseases. And there's a weird case where we mixed together the past and the future. And there was a woman in Zagreb who was a virologist who had a tragic recurrence of her breast cancer. And it wasn't good. And the first time around it wasn't good. And she had to have a breast removed and come back, and she couldn't stand to do the chemotherapy. But she knew from her reading, and they all know this, all the medical people know this, that every now and then, if you've got somebody with a really bad cancer and it's just progressing like gangbusters, when they get a bad infection, suddenly, sometimes the cancer can slow down or even go away entirely.
Wow.
Because the trouble with the cancer is that it's your own cells gone a little bit bad, but because they're mostly your own cells, your immune system says not going to touch you. And when you get infected by a virus, every now and then that wakes up the immune system to go in there and knock it over. So this woman, knowing that she could not possibly stand another bout of chemotherapy, the last bout just knocked her around, she, as a virologist, went chasing and found a fairly tame measles virus and a fairly tame virus called stomatitis. And then she grew them in her own laboratory, and in the interest of self-experimentation, a wholly different bag of worms there, she then got a friend to inject them into her cancer. And then they observed on the MRI that the cancer seemed to be getting less. Now, the word cancer, crab, means something that grabs onto your tissues and infiltrates and hangs on really tight. So they could see the cancer was shrinking, and so they went in, the surgeons, to remove it, and they found that it was no longer grabbing like a crab, but in fact it had let go of her pectoralis muscles and was now just like a little ball shrinking away. And they got the little ball out and they looked at it and they found it was infiltrated with her own immune system cells. So I'm seeing genetics, to answer your questions, what's the big ones? Genetics and medicines are going to be really big things affecting our future, but then that's on the background that we're seeing this massive flow of money from the poor to the wealthy in the USA at the rate of $1 trillion a year, and that's another factor. So there's a whole lot of things going on.
Yeah, that's fascinating though.
Thanks,
Thank
Sam.
you so much.
Wow, that is fascinating. Let's say that we do want to stay with AI. Christy in Newtown, what's your question?
Hi, doctors.
Dr. Christy, welcome.
Hi. So I've been doing a lot of research, and my question is, in terms of AI with quantum mechanics and quantum computing, do you think it will be the end of humanity?
Right. Well, luckily, I've been able to talk to a very clever person called Geordie Williamson, who was brought up by hippie parents out in the land at Moss Vale without any electricity, so he had to do a lot of thinking and hanging around. And now he's a mathematician. And when he says he's a mathematician, people say, hello, I think I'll go over and talk to somebody else. And when he says, I'm a mathematician doing AI, they then start talking to him. And so he gave this wonderful lecture up at Woodford, and he quoted, I helped him sort of work the lecture up a bit. I didn't do much except sort of, he did all the hard work. And he quoted the three gods, I forget their names, of AI. And the three gods of AI have got completely variable opinions. And one of them is, will AI ever get intelligent? And they vary from definitely yes to definitely no and don't know. And these are the three gods who helped set up AI. And the second one is, will AI destroy humanity? And the answers vary from very high chance to nah. So the answer is we don't know. But we do know that what we've got today, and we call AI, is not. It's almost all predictive texting on steroids. So if I say the word I, as in me, my, the next word will almost certainly be am, A-M, but it won't be ham, as in the food from the pig. And so that's all the AI does. And truth is not one of its requirements at the moment, and we don't know how to make truth one of its requirements yet, unless that's a whole complicated thing. So to answer your question, definitely don't know. How's that for a fuzzy answer? Sorry, Dr. Christie.
That's okay. Thank you.
But keep an eye on Geordie Williamson at the University of Sydney and just follow his work. He gives really nice summaries.
Can you tell me a little bit more about the way, though? Because, you know, not to get too deep into it, but could AI potentially destroy humanity because of the resources required to fuel AI? Can you explain to me how AI is bad for the environment?
Well, firstly, to run AI needs maybe 0.5% of the world's electricity. It's just chewing up electricity like crazy, maybe 0.25%, and that will increase. The worry about AI is that it looks around the world and says, mate, these humans, whatever they are, there's not many of them. You could fit them all into a box 1 kilometre by 1 kilometre by 1 kilometre. Mate, these humans, they've made a real mess, I reckon we just get rid of them. And the AIs decide among themselves to get rid of us, and they could do it if they were intelligent, and which we don't know if they'll ever become. By the way, there's two different forms of AI. What we've got at the moment is generative AI, which means it comes out with a word and then it generates the next word. Whereas what we are really wanting to head for, but we haven't done, is general AI, which is like you and me. Will I do this? Well, yes, I'd like to, but I've got to meet my friend and I've got to get some coffee and I've got to buy some nuts. And so we can juggle all of these things, and the AIs can't do that yet. Will they ever be able to do that? We don't know. So what was the question again about the AI?
The concerns around the amount of electricity it takes to power this thing that is just making our lives easier in the interim or in the immediate.
Your life is definitely easier unless you happen to be a writer for the National Geographic for Sports Illustrated or all these marketing people around the world. And there's so many jobs that are going away. But then there's the other side of the coin. Dear audience, look up UBI, Universal Basic Income, on Wikipedia. And there is enough money in the world that everybody can have a decent living and be able to buy a set of shoes if their shoes get a hole in them, or buy a watch or something, without ever having to work. There's enough money around, and that needs a change in our thinking. And we've got this weird mix, I think I've mentioned this before, of medieval institutions where you have to, if you want money, you got to work for it, and 200,000-year-old thinking, and godlike technology in our hands. We're at a real weird point in our evolution now.
Dr. Karl, earlier we had a question about the UV index. What is the metric? 0439757555 is also where you can text in your follow-ups, your comments. Someone's saying this UV index goes up to 20 with anything over 11 classed as extreme. Someone texted in saying, just off the back of that UV index question, I did a quick look around Australia and the max UV index in Darwin today is 14.
Wow,
Someone's
so it does go
saying
over 10.
Yeah, someone's saying orange, 13 today.
So there is a saying that if you want to know something, you've got to be able to measure it. How do they measure it? How do they get this number? Is it somebody just going out, sticking their finger in the air when they've wet it and saying, oh, I'm picking 13? How do you measure it? Where is the machine that gives you this magic number? This is what I don't know.
And how do you continue adding numbers to it as heat increases? We'll pause that for now. David in Brisbane.
Dr. David.
What's your question?
Yeah, hi, doctors. My question is, when I hear my voice back in a recording, I pretty much don't recognise my own voice. Is there any reason behind that?
Because you're hearing your voice through your ears. So you've got this complicated system of the lungs and the larynx and your mouth, and out comes this sound through your mouth and is directed forwards, and some of it comes around back into your ear. You will pick it up. It'll travel that way. But you're getting a lot through the bones. You're getting a lot of the lower frequencies. And then when you hear a recording, you're getting a different mix. You're only getting it through the air. So that's why you never recognise your own voice. It's always a surprise to yourself. And in fact, even if you lose your external ear apparatus, you can still hear. And Beethoven was famous or infamous for the fact that when he got to the stage of being, before he got totally deaf, and by the way, if you listen to his later string quartets, they were composed while he was totally deaf, he never heard them, what he would do would clutch a pencil between his teeth and then shove the pencil hard up against the piano and bang on the piano. And he was notorious for breaking pianos because he would bang on them so hard and he would get some hint of what he was hearing. So he was hearing the lower frequencies more than the higher frequencies. So it's that difference that when you're listening to your own recording, you're hearing it only through the air, not through your bones, bringing the sound from your inner airways up into your hearing apparatus.
Because it's almost more bass heavy when it's going around your head, isn't it?
Yeah.
So then sometimes you'll hear yourself back on a recording and go, why do I I speak high.
Yeah, that's
you
right.
know? Yeah, I've got
You're
a
not getting
higher
that
voice than I
bass.
thought. Yeah, interesting. Thanks, David.
Thank you, Dr.
All right,
David.
thank you.
We got Lo from Awabakal country. Lo,
Welcome.
this is maybe going to be a bit of a mind melter. What's your question?
Hi, doctors. My question is, I recently saw a headline about a second universe running backwards in time next to our universe. And I'm really interested to understand a little bit more about time, reality, and other possible universes.
Running backwards.
Yeah. Okay, so the first thing is look out for the headlines. They're just trying to trick you. I have several friends who are pretty knowledgeable and quite intelligent, and they keep on ringing me up saying, what's this I just read about how the latest discovery of the, and the insert name of neutrino telescope, just the JWST, has broken all of our physics. No, it hasn't broken our physics. With regard to the headlines about the parallel universe going backwards, we have not discovered it. We have zero evidence for it, but it's just another case of, is that quiet period over Christmas? Actually, did you ever hear that thing about the news and Attila on Triple J?
No.
One day my wife and I were lying in bed around Christmas some years ago, and Trent O'Keefe, otherwise known as Attila the Trent, came on to do the news, and he said, "G'day, Attila the Trent here with the 8:30 news." Bugger it, mate, there's no bloody news.
Oh, really?
I'm not going to waste your time trying to pretend there's some news and fill the whole 5 minutes. I'll come back at 9 o'clock, and that was it. Right? Forget this 5-minute segment. And he came back at 9 o'clock and said, look, there's nothing. There's no point. I'm not going to waste your time. Back to the music. And then finally they came up with some news. So this period of the year, around Christmas, New Year, traditionally the politicians and the business people are all away. So it's kind of considered a low news period. So that's why we get these headlines. Okay, so getting back to NASA did not discover another universe. But it is possible for time to go backwards. Look up CPT, charge something parity, charge time parity, CTP, charge time parity. And if charge and time, charge, electrical charge, and time could run backwards, you could have a parallel universe going backwards, and there's a whole bunch of philosophical implications from that. But have we discovered it? No. Do we have any proof that it exists? No. Could it exist? Maybe. But we've got zero proof.
Mm-hmm.
There you are.
Does that help, Lo?
Sorry, Lo.
Thank you. That helps me a lot. I will stop clicking on clickbait.
Oh, we're wired to it.
We
it's so interesting.
We all do. Hey, Mitch in Brisbane.
Dr. Mitch.
You got a pretty crazy hypothetical. Talk us through it.
Good morning, doctors. My question's about our fingers and our mobile devices. If you happen to cut off a finger or thumb you use to unlock your phone or whatever, how long would that digit be useful being severed until you can't unlock a device?
So, Mitch, let me get this straight. Let's say I'm in some sort of spy movie and they cut off my finger and therefore I can't unlock my phone. Are you saying I should, I get that, I pick up that severed little digit and I swipe it across myself with my finger?
Yeah, would it still be good for, days, months, or would, the fact there's no blood flow in the digit stop it?
Dr. Karl, what do you reckon?
Well, there's a variety of answers. If you're looking at, they're working on a capacitance effect, that would vanish almost immediately. If they're trying to recognise the fingerprint would maintain some degree of structural integrity for, I'm guessing, for a few days. I don't know how long. This is a very bizarre experiment, but let's just follow down this pathway. I was reading about the tent girl in Kentucky this morning, and they couldn't get fingerprints off her because she'd been dead for 2 weeks. So after 2 weeks, you're not going to get anything, right? Because it will have, been attacked by your own internal bacteria that will attack it and eat it. You see, the thing is that modern fingerprint sensors, like the ones on the smartphone, they don't just use pattern recognition. They also use electrostatics as well. And they're using capacitive as well and radio frequency technology. So they're picking not just the pattern, but the fact that there's living tissue associated with it, stopping the situation where somebody gets your fingerprint, like in the movies, off a glass, and they copy that fingerprint and they put it onto a little bit of plastic and they shove that over your thumb and then they shove it onto the phone to activate it. Yeah. So assuming that that's how they work, that they don't use just the picture but also the capacitive and the RF, it would stop working within minutes. So, but they definitely don't do it, but it's an interesting thought experiment.
Definitely don't do it. But it is interesting because I watched The Batman.
Oh, yes.
Starring Robert Pattinson as the Batman. And spoiler alert! But basically, there is a moment where, you know, one of the bad guys, he cuts off this person's finger and then attaches it to a USB. Anyway, but they need the fingerprint.
Yeah.
I've seen that,
Yeah.
yes.
So they plug in the USB and it needs a passcode or, you know, identification. So they use the finger to then
Yes.
fingerprint. Yeah. And that was at least 24 hours after that man had been killed.
Well
and truly.
And we know that the movies are true, Dr. Karl, so.
they are. Okay.
No.
So there you are. Don't do the experiment. I hope nobody has ever done it.
I know. It is, you know, very, very... I like where your mind goes, Mitch.
Thank you.
All right. We got Steve in the Northern Beaches. Dr. Steve, what's your question?
Hey, doctors. My question is, how has modern medicine impacted the human genome if genetic diseases are becoming more common, if, like, now that we can treat them and we used to not be able to treat them?
Well, the example is cystic fibrosis, which used to be that nobody survives cystic fibrosis. It's a disease of sodium metabolism, and the way that people would die from it, usually in their early years, before they had a chance to have children, was from clogging up of the lungs, just mucus in the lungs all over the place. And now they've got to the stage where they survive into older years and they meet with other people who have cystic fibrosis and they pass the gene on down through generations. So what exactly are you asking? Is the percentage of people with cystic fibrosis increasing in the population? Yes, a little tiny bit. It's very small in Westerners. I think 1 in 70 people has the gene. In Asian people, I think it's close to 0. So what sort of things are you thinking of that we're keeping people alive? Take me on this one. I'm a bit confused. Take me more.
I kind of just meant, like, all genetic diseases that, like, say 100 years ago we wouldn't have even known existed, now we're, like, genome tracking and all that to try and stop them. Does that mean that they'll become more popular throughout the whole human genome, or?
Yes and no. On one hand, because we're keeping those people alive and they can have babies, yes. But on the other hand, we are getting to the stage where we can actually modify the human DNA. And in October 21, we modified the DNA of a man who had lost the ability to make insulin, and we modified his pancreas back to what it was when he was born, and he could now make insulin. And we're heading, and it turned out we were able to do that a few months ago with a young person of African descent in America who had sickle cell anemia. So we'll be able to fix those genetic diseases. So both are happening.
Cool.
Yeah, so we are keeping them alive, which is a good thing, and also we've been able to fix them, which is another good thing. Complicated story, though. Wow.
Josh from Castle Hill, what's your question?
Hey, doctors, how's it going?
Great.
My question is there any other object, besides, from my understanding, a black hole and your eyeball, that when light is in the presence of it, it will absorb it no matter what? Because my understanding is that matter gets broken down and absorbed into a black hole. After it passes the event horizon, it turns to something they call information. But when light reflects off a surface of matter, it kind of does a similar thing going into your eye.
It is complicated. So firstly, when stuff goes into a black hole, once it crosses the event horizon, as far as our current physics tells us, it's gone forever and we don't know more. And you did touch upon the information paradox. There's a whole page on that on Wikipedia, read up. With regard to the eye, you can actually have some light escaping. So if you do a flash photo of somebody's eye at night, when the pupil is large, you can get what's called the red eye, and what you're getting is a reflection of all the blood vessels on the inside. At night, when you're driving and you see a nocturnal animal at the side of the road and it happens to look at you and the lights sweep over its head, you get a white reflection. They've got a special reflective layer behind the retina called the tapetum, T-A-P-E-T-U-M, which is kind of silvery, and it reflects the light, so the light gets 2 chances at exciting the retina, firstly on the way in and on the way out. But so the black hole is the only thing that fully absorbs all information and light the eyeball, not so much. Big, complicated question you've asked there, Dr. Josh. Look, you must be a very deep thinker.
Yeah, we like it.
No, thank you. Have a great day, guys.
You too. We got Gary in Noosa to take us out. Dr. Gary, what have you got?
Yeah, morning, doctors. Kind of similar question to the last listener. I was reading on Facebook this morning that it takes 15 seconds for the eyeball to process the reality in front of it to hit the brain, let alone for the brain to come up with a reaction or anything. Is that true?
No. Facebook lied, as it does when there's advertisements of me selling stuff for tinnitus, high blood pressure, better handwriting, and ... fix your joystick. ... We'll stop right there. Ignore them, they're lying. Secondly, the period of time is 0.3 of a second between when light hits your retina, gets turned into electricity, gets processed by the retina, which is an intelligent processing station, then gets sent back to the visual cortex, one on each side, at the back of your skull, and then gets turned into this full 3D colour vision. 0.3 of a second, not 15. Facebook, unfortunately, lied to you. Don't believe everything you read on Facebook. I'm sorry.
Can that differ from person to person or animal to animal?
Yes. So if you go look on Wikipedia, look up the letter P for Papa 300. P300 is that you get this spike in electricity as something goes into your consciousness, and the P300 is when the light landing on your retina finally appears as information, like there's your mother or a hamburger in front of you. Different animals have different reaction times. So the eagle has got a much faster reaction time, and it's of the order of like 3 times faster than us, because it's got to find moving targets in the air which are trying to avoid being eaten. Is that kind of helping?
Absolutely. No, that's all good. Cheers, doctors. Thank you very
Thanks,
much.
Gary.
Thank you,
if you're
Dr.
just
Gary.
joining us as well, we just dispelled another Facebook myth. You can listen back via the Science with Dr. Karl podcast. It is our first episode of the year, Dr. Karl, so I wanted to give a prize to the best question.
Which is?
Which is?
My question's about our fingers and our mobile devices. If you happen to cut off a finger or thumb you use to unlock your phone or whatever, how long would that digit be useful being severed until you can't unlock a device?
I love the mental image of this question. So, Mitch and Brizzy, you are getting a Triple J prize back, which includes a copy of Dr. Karl's book, A Periodic Tale. And Chris has actually texted in saying modern fingerprint sensors used for access control into buildings map the fingerprint, but also the blood vessels within the finger. They also require a pulse to be present. I wondered that. Would it still need the warmth in order to be used?
Well, it wants the pulse, the on, off, and you could fake that, but so who said that to us?
Chris.
We love you, Chris.
Thank
you
Chris.
so much. Thank you for giving us extra information.
And that's it. Thanks so much for listening to the first episode of Science with Dr. Karl for 2025. We are so stoked to be back with you. If you want to continue the discussion or let us know if you like this episode, you can do so via Triple J's YouTube channel. YouTube.com/Triple J is where we're uploading each episode for you to listen back to. You can also do so with rating and reviewing via Spotify podcasts or Apple podcasts, or just via the Triple J app. My name is Lucy Smith. This episode was produced by Sarah Harvey. We'll catch you next week. Bye.
Dave Marchese here from the Triple J Hack team. Hey, if you love Dr. Karl's podcast like I do, you might enjoy the Hack podcast as well. Each day we bring you the news that matters to you, from the latest science on climate change to what's happening in politics and news around the world. The Hack podcast. It's your daily fix of the news you need to know. Get it wherever you're listening now.